let's get in to what we're going to do today. All right. So the first thing that I want to start with is I would like to start with going through exactly how we're going to finish up these last 2 weeks. So you probably heard me harping on it last week when we were doing our lecture videos. We are currently on the 7th. Today, we're going to talk about how an atom emits light using orbitals, and we're also going to talk and make sure everybody understands orbitals. Tomorrow, we're going to talk a little bit about the history of the atom, because I have not physically been with any of you when you guys learned it all about the history of the atom, so we're going to make sure everybody's good with that. You will have a review day on Wednesday. Thursday, those of you in class will do the flame test part 2. Those of you at home, you're going to do it next week, so you do not have to come on Thursday. And then Friday is your test. Everything in your packet that you are holding, all that business, okay, that will be on your test on Friday. You will need your periodic table for that test, so make sure you have that with you. And I will know more. We're going to finalize it by Wednesday, so you'll know exactly what's on it on Wednesday. Okay, so that's what we are looking at as far as the end of this week. Test on Friday. Then, if you want to take a look at what we're going to be doing for the last week of the semester, let me take you into what I think we're going to do here. Okay. For the last week of the semester, we're not going to start a new unit. That would be silly. And there are no semester exams. Okay. However, we are going to give you a little semester exam in here, if you will. I will give you Monday, Tuesday, and Wednesday to work on the review packet. So those of you physically in class right now, I'll give you the review packet on Friday once you're done with your test. Okay, and then you will have Monday, Tuesday, and Wednesday to work on it. And then on Thursday, we're going to give you a semester exam. Now, I use that very, very loosely. It has to be done in 40 minutes because we don't have like a double block period. So it's not going to be a long test. It's going to be on Schoology. So it's going to have to be a review. Or a multiple choice. And the other thing is that I will probably, more than likely, 99.9% sure, I will let you use your review packet on the exam. Okay, so it's kind of the main reason why you have a semester exam is so that you think about the material one more time. What was a homogeneous mixture? What is the meniscus in a graduated cylinder? Just to refresh. So this semester exam won't be its own grade like it used to be, because it's not really a semester exam. It will be another grade in this semester that I actually think will help your grade, because you'll have 3 days to do the review packet, and then we'll do the semester exam. And then on that Friday, they will do the second half of the lab that you guys are going to do on Thursday. So you will have nothing to do that Friday. Okay. Does that make sense? So we have a big test on atoms this Friday. We have a semester exam the following Thursday. Okay, so it shouldn't be too hard. Like I said, I'm not going to write the semester exam to be super tricky. I just want it to be a review of all the information that we've gone over in this semester before we leave for winter break. Okay. All right, so let's get into what we're going to do today. So you should have atomic structure bell work number 5. This is going to refresh what we learned in live class last Wednesday. So if you didn't show up, I'm banking on the fact that you watched the lecture video. So I want you to tell me what the difference is between an orbit and an orbital. What were some of, and I will not ask you this on a test, but just in your mind, bring up some of the shapes we talked about of the orbitals. What is the difference between Aufbau and Hund? Okay, so if you have your notes and you need to flip back to do those, you can. And then there are a couple orbital charts. Can you fill in an orbital chart and give me an electron configuration? So I need to see where everybody's at because I haven't seen you in a while. I will check in with you guys at home in a second. But I'm going to walk around. So what you're doing is you're finishing the whole front page of bell work number 5. And I'm coming around to see how you're doing. Yeah. So I guess I just assumed that everybody was going to be caught up. So here's the thing. If you have no idea what's going on in this bell work, that's probably because you did not do history of the atoms notes number 5. If you did not do the notes from last week in the live class, you won't know how to do this bell work. So I want everybody to, if you were history of the atoms notes number 5, part 5, if that is blank, you have to at some point, why don't you write at the top of this, go into week 15, Wednesday folder, okay? And then this is the lecture that you guys missed here. Okay, so as you can go along, you'll see that we'll do history of the atoms. We'll do Bell 4, and then history of the atoms notes part 5. Okay, so you have to watch that. If you don't know what we're talking about, that's because you have not done this lecture. Okay, everybody online has done this lecture, and I see a lot of people in the classroom have done this lecture. So we're going to move forward with the class today like people have done this lecture. But again, if your history of the atoms notes number 5 page is blank, you need to go into week 15 Wednesday folder. I mean, you need all of these notes to be filled out before the test. So you need to go. If you need help finding any of the lectures, let me know. But you will not know what we're doing if you did not do this lecture. Okay, so for those of you that did do the lecture, let's talk through this, see how we're doing here. All right, and if you didn't do the lecture, though, you might want to hold on and just see if you can't pick up a couple things as we go along here. Remember, Bohr was the first person, and he said that electrons move in these predictable little paths around the nucleus, that they start on one side and they rotate, they come back around. You can always tell where they are, like planets around the sun. We know that that is incorrect now. Okay, you don't really know where an electron is. So based on Schrodinger and de Broglie and Heisenberg's work, we don't know exactly where electrons are. So what they did was they paid a little homage to Bohr and just made it really confusing for everybody. And instead of orbits, they called these things orbitals. And what orbitals are regions of space with a high probability of finding an electron. Okay, so they're no longer these little paths that electrons travel on. Now they're these regions of space. And if you watched the lecture last, or you came to class, I had these models. I guess I should have kept them out. They were telling you the S, P, D, and F shapes. Remember, S was a sphere. There were 3 P orbitals. They look like pears. And then the D shape looks kind of like daisies, so on and so forth. Whatever you guys thought. And then the F shape were doubled the Ds. Okay. So then we moved into, instead of Bohr's model, we moved into our current model called quantum mechanics. And quantum mechanics uses the orbital chart. And there were 2 scientists that helped us solidify the quantum mechanic chart. The first person was Aufbau. And Aufbau said that electrons fill the lowest energy level first, and that is closest to the nucleus. They fill in the lowest energy level first, and that is closest to the nucleus. So that is Aufbau's principle. All right. And then Hund's rule, though, says electrons don't like to share very well. They're both negative, so they repel. So electrons will only, one goes in an orbital at a time. Okay, so if you can spread your electrons out, please do. Remember, you may have no more than 2 in an orbital, though. Orbitals hold 0, 1, or 2 electrons. Okay, but you may only put 1 electron in an orbital at a time. All right. So then you need to get your periodic table ready and near you. For the orbital charts at the bottom, this is how we are going to know where the electrons are or are likely around the nucleus. Okay. All right, so for instance, the first one is nitrogen, and it's neutral. So you find nitrogen on your periodic table. What is the atomic number for nitrogen? The number at the top of the N is 7. So if it has 7 positive and it's neutral, that means it has how many negative? It also has 7. So what you're going to do is you're going to take your pencil and kind of in the lecture. So if you quick recap, these are the orbitals or the regions of space where there's a high probability of finding an electron. There is a nucleus that is close at the bottom energy level because it's where low energy is. And every time you have an electron, you're going to put a slash in for an electron. So a little slash here means an electron. So we have to find home for 7 electrons. Aufbau says you always fill in the orbitals in the lowest energy level first, closest to the nucleus. So I'm going to put I need 7 slashes. So I'm going to put 1 electron, 2 electrons, 3 electrons, 4 electrons. Now I have to find space for 3 more. Hund's rule says you place 1 electron in its own before doubling up. So I have 4, 5, 6, 7. So what you're showing me with this chart is where the electrons are, the energy level, and the shape that they are most likely in around the nucleus. Okay? Now all you have to do is write your electron configuration, and you just write what you see. So you write the energy level and the shape first. So this is 1s. And how many slashes do I have in 1s? I have 2. Then I have 2, energy level 2, shape S. I have 2 electrons in there. And then the next one I put electrons in are 2p. And you only have 3 slash marks in there. So that is 7 total electrons there in the first energy level in the S shape, the second energy level in the S shape, and the second energy level in the P shaped orbitals. Okay. Germanium is a little bit larger. If you look up germanium, it has 32 protons. So to be neutral, it'll need 32 electrons. Please note, you see 1s, 2, 2s, 2p, 3s, 3p, and you see another 3d here, but this 4s just happens to be closer to the nucleus. So we fill 4s before we fill 3d. That's just the way it goes. So you just fill it up. Aufbau would say you fill it up closest to the nucleus first. So let's find a place for 32 slashes. 1, 2, 3, 4. Spread them out. 5, 6, 7. Then you go back and double up because of Hund. 8, 9, 10. 11, 12. Spread them out. 13, 14, 15. 16, 17, 18. 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And then you give them their own because of Hund, 31, 32. If you were to double them up, it would be wrong. Every electron wants his own space if possible. Okay, so again, what are these slashes? You are telling me what energy level and what shape orbital your electrons are around the nucleus. So now we just have to write down what we see. In the first energy level, there is an S shape and it has 2 electrons in it. So 1s has 2. Then we're just reading. Follow along the bubbles. The next bubble up says 2s, and there are 2 slashes in that one. Then the next level up says 2p, and there are 2, 4, 6 slashes in that one. So 2p6. Then we have 3s. Has 2 slashes in it, or 2 electrons. 3p has 6. 4s has 2. And again, you're writing. What you're doing is you're telling me where the electrons are. 3D has 2, 4, 6, 8, 10. So 3D 10. And then last but not least, you have 4p has how many electrons in it? 4p has, perfect, 2. Okay, so there are a few more on the front here. There are also another page. It says Orbitals Charts Practice number 2. If you need practice with these here, the key is in the Monday folder and ready if you want to do practices of these as well. Okay. However, I was going to keep going here to kind of make sure. So again, if you are very confused as to what is going on, I understand that. You just need to make sure you watch last Wednesday, week 15, Wednesday's class. Okay. But with that, we have to actually go back to that paper. Okay. So let's have you go History Atoms notes number 5. We kind of, if you were watching it or following along with me, you're probably like, turtleneck, she didn't finish that whole note, and that's okay. So on the back, I stopped right underneath the orbital charts practice. Okay. So let me take a moment to refresh. So you're not writing any of this down. We're just talking very quickly. How an atom emits light. For instance, I have a laser pointer right here. The laser pointer is red. How is red coloring coming out of this laser pointer? That is the question. So before I push the button on this laser pointer, the atoms in the light bulb here are at ground state. And you're not writing this. We're going to write it in a second, but this is just a reminder. And when you're at ground state, your electrons are closest to the nucleus in the lowest energy state. Then when I push this button, I run electricity through that light bulb, and that adds energy. So this is something we went over a million times last week. Hopefully you know this. And when you add energy, these electrons jump to a higher energy level. Okay. When they have jumped, that is called the excited state, where the electrons are farther away from the nucleus and they are high energy, but they can't stay there forever. So eventually what happens is the electrons fall back down. Oh, come back. Fall back down. And as they fall back down to the ground state, they release a photon of light. And so what the color you're seeing here is the photons that are being lost by the electrons as they fall. Okay. Now, photons are different colors because they have different amount of energy. So this electron is falling about 3 orbitals, and so it's giving you off about a green color. Remember, high amount of energy near the UV. So if an electron maybe fell from a really far length, that would be a blue color or a purple color. Low energy in red. Okay, so this was a lot of stuff we did last week. Hopefully you're feeling good with that. What I want to do is this is using Bohr's model. I want to use the orbital chart instead. So go ahead, and on the back of notes number 5, we're picking up right here. This is where we stopped on Wednesday. It says electrons start at the lowest energy level. Electrons like to start at the lowest energy level. That's Aufbau. However, when you add energy and these electrons jump out, that's breaking Aufbau's principle. So this is actually one of your questions in your lecture questions today. Can you think of a situation that violates this principle? Aufbau's principle is violated by the excited state, and I'm going to show you an example of that right now. When the electrons jump to a higher energy level, they defy Aufbau, but then they always fall back down. Okay. So let's look up sodium underneath here. I'm going to show you exactly what that looks like. Sodium has an atomic number of 11. If it's neutral, that means it has 11 electrons as well. So I would go through and we're going to take some notes on this piece of paper right here. I'm just going to do it on another slide because I'm going to blow it up a little bit bigger. Okay. So we're going to do the same process. How does an atom emit light? But this time we're going to use orbitals. So I would put a number 1 next to the word ground state and remind yourself that ground state is when the electrons are low energy and closest to the nucleus. Low energy and closest to the nucleus. Yeah, same page, I just zoomed in a little bit. So, yeah. Ground state. So what you're going to do when you're doing the ground state, if I asked you on the test on Friday, which of these is the ground state for this atom? It's the normal one. We said sodium has 11 electrons. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is the ground state for sodium. Okay, so the atoms in the filament are in the bulb of my pen right now, my laser pointer here in the ground state. When I push the button, that adds energy. So step number 2 is to add energy. Perfect. Once you've added energy by either electrical energy, you guys are going to do a kinetic energy today. I'm going to do actual light energy today as an example, all that kind of good stuff. Then the electrons will jump to the excited state. And in the excited state, the electrons are on the highest energy they can be, and the electrons are far from the nucleus. Remember, the nucleus is down here. So if I ask you on the test, which of these is the excited state? Well, if this is ground and you add energy, your electrons jump. Now, there is a mathematical equation you can do to figure out exactly how high up they jump. I do not care if you can do that. You just take your 11 electrons and you put them up. So they jumped away from the nucleus. So I don't know, pick your favorite 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The electrons just have to jump. Okay. And the electrons jump. They can't stay there forever. So step 4 is that the electrons will fall back down to ground state. So for instance, we'll take this guy right here. He's going to fall back down. And as he falls back down, that's when he's going to release a photon of light. And light is what you see on the color. Okay? Awesome. So I would expect you to know these 5 steps by the test on Friday, and also be able to tell me which one's ground state and which one's excited state on an orbital chart. Okay? Does that make sense? Awesome. And again, if you remember how we went through with Bohr, this is no different. Just bubbles close to the nucleus, and they jump up to bubbles away from the nucleus. Okay. All right, so the last thing that I would like to do today with everybody is do a little demonstration that I can show you. Remember how we said that red light has low energy and purple light has high energy. I have some laser pointers here, and this is called phosphorescent paper. So what I'm going to try to do is see if we can. All right, turn this off. Mr. DeChant, will you turn the lights off for me? All right. Oh, I'll go over to my actual. All right. So we're talking about lasers.